Just to introduce the next speaker, I've got John Rogers. John is the CEO of Locust Bioenergy Solutions. He's an experienced industry presenter that advocates for developing disruptive green technologies to maximize sustainability and profitability of oilfield operations. He has more than 30 years of experience as a seasoned oil executive, previously holding leadership positions including Global Technology Director at BP, Global Head of BL Oilfield Services at Clariant, EVP of Champion Technologies, and Managing Director of Sasol Oilfield Chemicals. John is originally from the United Kingdom and a fellow of the Royal Society of Chemistry. He has a BA in chemistry from the University of Liverpool, an MBA from the University of Durham, and is a holder of 4 patents. John, would love to hear what you're going to be talking about. We'll open the stage for you to discuss optimized filtration and oil recovery in SWDs with biosurfactants, based injectivity aids.
Great. Thank you very much. Well, I'd like to thank the Produced Water Society for this opportunity to talk today, and hopefully I'm not going to rehash over too much of what you've already heard. The one thing I always get nervous about when people say sustainable and green is that people think chemistries like these are not robust. I grew up in the oil and gas industry where if something was green, it normally meant it wasn't sufficient or you paid more for it. There was always some sort of compromise. And what I'm hoping we're going to show you today is that's changed. We've taken products that 10, 15 years ago are only being used for pharmaceuticals, they're only being used in personal care. And this was the reason why a small pot of oil of Ulay used to cost $40 for about an ounce. What we've managed to do is make these products at scale, very robust, and I think they've got a big role to play. Not in replacing what you do now, but supplementing what you do now and getting a lot more efficiency. So a little bit of basics. I'm sure you all saw this great report from B3 Insights in last month's World Oil. And surprise, surprise, we're running out of SWD disposal space. So they say at the moment, we are producing about 15 million barrels of water a day in the Permian Basin. About 10 of that's coming from Delaware and 5 from the Midland Basin. And that's going to grow. That's going to grow to 19 million in the next 4 or 5 years. And obviously the concern is that a lot of this water is associated with some of the premium oil producing wells that we have in Texas. And this is going to be a real problem, especially when we talk about things like seismicity. And I think it's obvious now that it is an issue. There's some statistics out that says before 2014, there was a total of 24 events, earthquake events of magnitude 3.5 and higher. And since 2014, which is the correlation with the fracking and disposal, we're up to 122 plus, 3.5 and above, and some actually hitting 5. So as everybody in this room will be aware, the state agencies in Texas, New Mexico have got the SRA areas, and the effect of that has been we have to minimize or even eliminate some of the injection that we do in current saltwater disposal wells. One of the calculations is that we're going to need at least another 100 SWDs in the next 4 or 5 years, costing about $400 million to do that. But I think there's an inherent problem we've got to deal with, first of all, is that when people calculated what we should be injecting into each of these wells based on that maximum allowable pressure that was set, we're not even getting close to that. And that's what I'm going to address. So why are we not getting the full utilization that we should do, and in fact it's getting worse? If utilization is what's the boilerplate capacity about what we're actually putting in, why is that gap increasing every year? One of the reasons for this, I think everybody's aware of this here, is some simple things. The water that we treat is solids laden. Even if we were to use every drop of water that we need for fracking from produced water, we've still got 70% of that 50 million we have to dispose of. And this water contains oil, it contains scale, it contains iron sulfide, it contains chemicals, it contains floc. Although we can say we do have specs for things like oil content, I think anyone who's dealing day to day know that we exceed those specs. Now, we're processing a lot of water. It's turned into a little bit of a commoditized business. No downtime. It's down to cents per barrel for chemical treatment. And it's a tough ship to make a U-turn. And again, I started off this conversation by saying we're not asking to bring in some tree-hugging new chemistry that you're going to have to completely change the way you set up. There's products now that can boost what you do now, and I'll show you some case histories. We mentioned emulsions. Obviously, if we're not taking the oil out in the skim tank, it's going through with the water, it'll get in the reservoir, it'll break up, it'll form emulsions like mayonnaise, which will stop the normal flow path where the water wants to go. We've got iron sulfide that's going to plug up the first stages of that reservoir we're trying to pump through. And the analogy I always use is it's like your swimming pool filter. Once you get a coating on the outside of solids, it doesn't matter how clean the sand is inside, if you can't get through that, you're going to have to increase the back pressure to get that water to flow through. And I think I've been in the business, in the oil business since 1984, and it's always been and probably always will be a cost per gallon, a pennies per barrel, and it probably will never change. But one of the things we have to look at is, okay, now we're forced maybe to look at something else. Maybe we're forced to look at more effective acids, to go in there and actually try and dissolve some of these scales, dissolve some of the sulfides, dissolve some of the iron salts, and actually maybe open up some of the reservoirs. But again, we're using, as an industry, the cheapest possible acid, the cheapest possible inhibitors that we can use. And one of the things, ESG is being mentioned, although in full disclosure, I don't think any of us here say that really any major decisions are being steered today by ESG considerations. I think it's something that's coming in, but there's some obvious things that are negative about what we're doing at the moment. The fact that in some of these SRAs, we have to now truck water to different zones, New Mexico water coming into the Permian to be disposed of. So whenever the footprint that we have for our operations becomes important, the fact that we're trucking around water to dispose of it has got to be one that is an easy target to minimize or eliminate. So where can we make a positive benefit in this very, very simplistic view of saltwater disposal? Well, the first thing I'll mention is, okay, what's a biosurfactant, which is what we do? The only thing I think people need to know is, think of a normal surfactant, which is something like a Dawn soap, which is that traditional SWD type surfactant, or maybe an NP9 that is used. What a biosurfactant is, think of it like a surfactant on steroids. Each one of those chemical sites you can see there is a site that can do some work. It can change the wettability of a surface to make it more water wet so the water flows through. It can break up and de-emulsify an oil deposit. It can break up a paraffin deposit. It can free up water blocks from this capillary pressure. But they're also very good, and one of the things that we use these products for is they're very good at separating oil and water. So one of the things that everybody wants to do is obviously recover more saleable oil. So we can get better efficiency at separating the oil. And we've got multiple case histories I won't go into this session, but I'll be delighted if people would contact me afterwards, where we can show that the amount of water, or the oil in the water that's going over, has reduced significantly. Then we come down to the issue I mentioned before, which is probably what, across the board, everybody faces every day. It's that solids-rich, grease, oil-rich chemical mixture that we're now trying to pump in. I mentioned about what we can do when we actually get in the reservoir. Well, again, clean up emulsion blocks. I've got a case history where just for 2 days, we injected a high-level dosage to complement what they were doing. And in 2 days at an artesian New Mexico well, we dropped the pressure, operating pressure from 1200 psi down to about 1,000. And we think what we were doing was clearing up a lot of the damage, the skin damage and the blockages in the reservoir to allow the water to flow through the channels it wanted to flow through. Okay. If I had any idea how to work this, I would. So what we're showing here is probably similar pictures to what you've seen throughout the 3 days here. Looking at the 2 pictures that are highlighted there, it's not about just what is the loading on your water, but it's also about how well is it dispersed. So one of the tests that we do just to sort of mimic how well a water will flow into a reservoir is this very simple millipore test. So think of a very fine coffee filter. On that funnel where it says rapid filtration, we put a little bit of vacuum on that tube, we pour in different waters, and you watch how quickly you can pass through that 0.45 micron tube. Now what you see on the left-hand side is obviously something that's not very well agglomerated. That mixture will settle pretty quickly, and in this particular test, will blind the filter pretty quickly as well. So what you end up with is, think of this as analogous to when the water first goes in the reservoir. All that solid's going to come out on the filter. The water coming behind it is going to be difficult to get through, and either your flow rate goes down or your back pressure goes up. What the biosurfactant does, and again, this is not just biosurfactant only, this could be a cocktail with whatever you're using at the moment, we're able to disperse it more effectively, so what you end up with is much more of that material actually passing through and not sticking through the filter. So to give you an example, the water you see on the left, without treatment, it took about 1.3 minutes to flow through. When we put the biosurfactant in, it took 10 seconds to go through. We couldn't pour it in fast enough. Now this is the actual lab data, or the test data on the field. So what you're looking at on the left-hand side is the blank. This is the untreated. The incumbent product on the right, which was an NP9 product, was basically doing nothing. And then we tried different blends. We tried different blends of the biosurfactant with a traditional surfactant, with ion control, with scale control. There's a lot of value here, low-hanging fruit, just by people optimizing the surfactants they're putting in. You know, get away from a tick-the-box, great, my treating cost per barrel is only X cents, but what is it doing? You know, are you wasting that money? Other thing I think is a great improvement, and we do a lot of this, is people are bullheading in acid, either on its own or they putting it in with something like xylene or a solvent. And what we're trying to do, obviously everything we put down whole, be it scale or iron sulfide itself, is going to be oil wet. Well, the acid can only dissolve what it can touch. So we get this a lot with stems and even when we go in with spearheads on acids. And what you find, that what we're looking at here is that just acid on its own, these were carbonate chips that we'd baked onto a mixture of oil and iron sulfide and chemicals, the flock, etc. And what you're looking at on the left-hand side is the same amount of calcium in each one. We normally use a much stronger acid, but for the sake of this lab demonstration, we use 1.5. With or without solvent, and what can you see? You can see that the one with the xylene is cleaning more oil off, so the acid's managing to get through and penetrate. But on the right-hand side, you'll see an acid with just 3%, not 8% of solvent, but 3% of the biosurfactant did a number of things. Obviously, you can see here now, by looking at the rate that the carbon dioxide is coming off, you can see just starting now that we've got a lot more acid digestion going on. For the simple fact we've managed to clean off more of the deposits. This is another reason why we know that we're cleaning up the well bore when we do these jobs. So you can see there a lot more bang for the acid. What you're also looking at is the surface has become water wet. So obviously we're pumping water in, we want a surface that is receptive to water, and we're not going to get oil and water mixing, forming emulsions. So you can see here that we've got this clear layer of oil, water-wet surface, but most importantly, look how little calcium carbonate is left because the acid's actually been able to do its job. So the final slide for me is this case history that we mentioned. We've got case histories from the Bakken, we've got case histories from Permian. I'm very proud to say that for this product we're talking about today, we won the Hard Energy Meritorious Award for engineering technology, and the same product I'm talking about today is actually a finalist in this year's World Oil as a water treatment program for the awards on the October the 22nd. But this is what we do. We were called in for a company in New Mexico that basically had hit the maximum pressure. They tried everything. They tried acidizing, they tried solvent washes, they tried surfactants. Nothing could get them below the maximum operating pressure, so they're starting to crank down. I mentioned before, we went in with just basically a slug of chemicals for 2 days. We think we cleared a lot of the crud that was in there, the shmoo, the mixture of iron sulfide and oil that you get, the scales, and they were able then to get back up to full maximum injection rate, maintaining below the pressure. So with that, I would very much welcome questions that you may have, or please, if you wouldn't mind to scan the QR code there and submit any questions separately. But I think we truly do have, as an industry now, some products that have been repurposed in from other industries that we can now make at the price point that are viable for the oil and gas, even the cents per barrel treating cost of water injection, and there's some immediate and significant improvements that we can make to our SWD injection. Thank you very much.